Confusion around plastics is not uncommon considering there are so many different plastic materials, manufacturers, and trade names. Added into the confusion is the fact that all of these plastics can be processed in different ways, resulting in very different physical properties. As an engineer or designer of plastic components, understanding these differences may be critical to your material selection, material specification, manufacturability of your part, and ultimately your final design. Sometimes a part is machined from plastic stock shapes. Maybe a rod, maybe a sheet, or even a tube. This stock shape may have been processed via extrusion, compression molding, or even some other melt processable method. Regardless of the conversion method, the base raw material for the stock shape was resin, pellets, or powder. The large chemical companies that make the resin have their own material data sheets that have been based on injection molded dog bones or test sample plaques. This is important to know because injection molding a material will yield certain mechanical properties versus other conversion methods. The injection molding process is typically used for high volume needs and consists of a quick turnaround process where hot resin is injected through a small nozzle into a mold at a high rate of speed, then quick cooled for fast release. Consider the molding of a long, thin tensile bar. The injection molding process of a long, thin component like this results in the alignment of the polymer chains as the melted polymer flows through a small nozzle into the mold. If the polymer is also a fiber-filled material like glass or carbon-filled, the resin fibers will also align. This alignment of the polymer and the fillers within the injection molded test sample will result in very high mechanical values. However, for a machined plastic part, you certainly are not making your part out of a tensile bar. As we said, you may be machining your part from an extruded shape like this plate. Extrusion of stock shapes is a conversion process where the resin is slowly pushed through a die, and the resin has time to slowly cool while it comes out of the extruder. While there is some alignment of the polymer chains in the filler while it moves through the much larger plate die opening, alignment is much less compared to that of injection molding. Also, the much slower speed of the extrusion process also equates to less alignment as the polymer and fibers have time to relax and settle into a more random structure. The extrusion manufacturers will actually measure their mechanical properties by machining their test bars directly from their stock shapes. Because of the reduced alignment, mechanical data for this process will be lower compared to the resin data sheet. There may also be a third processing method which could be used to make this plate, compression molding. In the compression molding process, this involves placing the powder or pellets into a mold and simply squeezing the resin under pressure and temperature. There is no specific orientation of the material and its fillers at all in this process. When compression molded test samples are machined and then analyzed, the mechanical properties will be even lower compared to extrusion machine samples or those injection molded test samples. As you can see, the mechanical properties of these varying processes can result in very different mechanical data. Many shape manufacturers will test their mechanical properties by machining their test bars directly from the stock shapes. So you have resin that has been injection molded versus stock shape data that has come from machined test samples. Here is an example of the exact same resin manufactured and tested three different ways. The resin is a 30% carbon fiber filled peak, and the resin has been injection molded into a test bar. It's also been extruded into a shape with the test bar machined, and it's also been compression molded into a shape with the test bar machined. This DMA curve shows the results, and the difference in mechanical performance is significant. A typical rule of thumb for fiber-filled materials like a 30% carbon-filled peak is that injection molding properties can be over 50% above extrusion properties, and the extrusion properties will be another 15% above compression molded properties. While these are just estimates, you can see where such a difference in mechanical properties could be extremely important to a design engineer. Why is one processing method used versus another? Often the processing method is driven by the size of the component required or even by the volume of the parts required. Injection molding of component is used when extremely high volumes of finished parts are required, and machined parts from stock shapes are required for smaller volume requirements where the cost of a mold simply is not practical. The decision between using extruded shapes or compression molded shapes is often simply based on the cross-section or size of the finished part. Clearly understand how you will be sourcing your plastic parts and the processing method which will be used. Be sure that the supplier you are using is also providing you the most accurate data. For machined parts, do not simply rely on injection molded resin data. And finally, if you are writing a material specification and calling out a specific standard or mechanical property, be sure to understand and incorporate these processing differences into your callouts. For example, there are both ASTM resin specifications and ASTM shape specifications. Think about how your part will be manufactured, use the correct mechanical data and the correct callouts to eliminate sourcing confusion, which can waste time and money. As always, Boedeker Plastics is here to help. Reach out to our technical team so we can help you navigate these topics to ensure your success. Please feel free to add your comments below, like and share this video if you found it helpful, and subscribe to our YouTube channel. Thanks for watching.